Disclosure. This educational content has been developed using artificial intelligence.
Ever wondered what that invisible force is that makes magnets snap together or push each other apart? It feels like magic, but it's pure, fascinating science. Let's dive into the amazing world of magnets. So, how do they work? It all starts way down at the atomic level. Everything is made of atoms, and inside these atoms are even tinier particles called electrons. Think of each electron as a spinning, microscopic magnet. In most materials, these electrons spin in random directions, so their magnetic forces cancel each other out. It's like a room full of people all pointing in different directions. Complete chaos, no overall direction. But in some special materials, like iron, cobalt, and nickel, something incredible can happen. When these materials are exposed to a strong magnetic field, their atoms can align. Instead of spinning randomly, a huge number of their electrons start spinning in the same direction. Now, that room full of people is all pointing the same way. This creates a unified force, and we call the areas where the atoms are aligned magnetic domains. When enough of these domains line up, boom, the entire piece of material becomes a magnet. This alignment creates an invisible force field around the magnet, called a magnetic field. This field flows out from one end of the magnet, called the North Pole, and loops around to enter the other end, the South Pole. You've probably seen this pattern if you've ever sprinkled iron filings around a magnet. It's this field that interacts with other magnets and certain metals. Now, why do opposites attract and likes repel? When you bring the North Pole of one magnet near the South Pole of another, their magnetic field lines link up, flowing from north to south, pulling them together like a perfect handshake. It's the most energy-efficient way for them to exist. But if you try to push two North Poles together, their field lines are pushing against each other, like two strong currents colliding. They can't merge, so they push each other apart. The same thing happens with two South Poles. And what about Earth itself? Our planet is like a giant magnet. Deep inside, the Earth's molten iron core is constantly moving. This motion generates electrical currents, which in turn create a massive magnetic field that surrounds our planet. This field is what makes a compass needle point north. It also acts as a crucial shield, deflecting harmful charged particles from the sun, protecting life on Earth. So, in a way, we owe our existence to this giant planetary magnet. From sticking notes to your fridge, to the powerful magnets in MRI machines that can see inside our bodies, and even in the electric motors that power our world, magnets are everywhere. They're not magic, but the science behind them is truly magical. It is a beautiful dance of atomic alignment, creating an invisible force that shapes our world in countless ways. I hope this has demystified the wonder of magnets for you. If you enjoyed this and want to explore more scientific marvels, make sure to hit that like button and subscribe to the channel. Thanks for watching, and stay curious.